Welcome to another Portworx demo. This demo focuses on how Portworx can provide automated capacity management, not only for Kubernetes pods with persistent volumes, but also virtual machines running on Red Hat OpenShift virtualization. We've all been through that issue when our stable virtual machine suddenly stops serving clients because it ran out of disk space. For some reason, this always seems to happen in the middle of the night when we're comfortably asleep in our bed until our phone rings. By using Portworx's AutoPilot feature, this operational issue can be automatically remediated so you can get your much needed rest. Let's take a look at how we can automatically expand capacity by using our AutoPilot engine. Let's start by taking a look at an AutoPilot rule. AutoPilot rules come in 4 sections. The first section is a label selector that defines which PVCs this rule should apply to. In our example, the rule will only apply to PVCs that have a key value pair of resize equals enabled. Only PVCs with this label will automatically be expanded. Next up, we have a namespace selector. Just like the PVC selector, this section defines the rule to only apply to namespaces that have a label of autogrow equals enable here as well. As a Kubernetes administrator, this gives you the flexibility to pick which applications will fall under this rule. Maybe you want all your namespaces to have this capability, and maybe not. The choice is yours. Next, we move on to the sizing conditions. In this section, you can specify when those PVCs will be expanded. In the example we show here on the screen, only PVCs that are over 30% filled will expand their capacity. Obviously, this number was used for a demo. In a production environment, this would probably be like 70 or 80%. But in our demo, we'll be filling a PVC to 30% capacity and watch it grow. Then finally, we see the actions section of our AutoPilot rule. This defines what we should do if the conditions above are met. Should our tagged PVC reach 30% full, what do we do with it? In this example, we're going to grow or scale up the PVC by 50% of its current capacity. This actions section also contains a maximum size of 400 gigabytes, meaning that this rule will continue to affect our PVCs until they hit a size of 400 gigabytes, at which point the AutoPilot rule will no longer grow your volumes. This is a good stopgap in case you have an out-of-control application that is spuriously chewing up storage space. If things grow that much, you might need an administrator to actually look at the application and stop growing the volume until it's fixed. Okay, like most Kubernetes objects, you apply the rule with the kubectl command line interface. Now we'll move to do a kubectl get on the PVCs in the VM namespace where our demo virtual machine lives. We can see that we have a PVC for our VM and that it is 33 gigs in size. If we rerun that command, we see that we have the resized enabled label. And if we do a get on the namespace, we also see our autogrow equals enable label on the namespace. If you remember how the rule was configured from earlier in the video, these key value pairs were what was used for the PVC and namespace in our AutoPilot rule. Now we can flip over to the console of our virtual machine and we'll run a script called disk filler that rather quickly starts using disk space. Now that our disk filler script is running, we can watch the Kubernetes events. At first, we see 2 events from AutoPilot. Initializing, which says the AutoPilot rule is in place, and normal, which says that the PVC was found that matches our rules and it doesn't need any actions taken. Later, as the disk fills up, we see 3 additional entries. Triggered, which means that the AutoPilot identified that the conditions have been met. Then we see active activations pending, meaning that the AutoPilot is preparing to make changes. And then lastly, we see the active actions in progress and actions taken, meaning that the volume has been resized. If we check back on our PVC, we see that it's gone up 50% from 33 gigs to 50 gigs of storage. And if we do a describe, you can see that the volume was resized in the events. Hopefully this demo has shown how AutoPilot works in a Portworx storage cluster and you've got some ideas on how to put it to work in your own environment. Thanks for watching.